Hello, welcome to Jamaica Virtual Learning. This is lesson 4 on vectors, proving that two vectors are straight line. I would recommend that you watch lesson 3, proving that two vectors are parallel to each other, because some of the ideas will be brought into this lesson as well. Well, to prove that two vectors form a straight line, it means that one of the vectors must be a multiple of the other. And also the two vectors must have at least one common point. So what this actually means is that first, the two vectors that you are proving should first be parallel lines, but because the lines, one line lies on top of the other, that is why it forms a straight line. So it's just proof of parallel lines, but one of the line lies on top of the other. That's why it forms a straight line. That's why we say they must have at least one common point. Looking at this example, triangle OAB. A is midpoint of OZ, Y is midpoint of AB, and X is a point on OB. We've been given the vectors. We need to put the vectors back on the diagram. So OA with the right direction, that is A, 2B, B. And with this, we'll be able to work out vector OB as 3A. And also, if A is midpoint of OZ, then vector AZ must also be A, so we can have vector OZ as 2A. Now, to prove that XYZ is a straight line, we can prove by saying that XZ is a multiple of XY. So we quote our notation like this, and also to confirm at the end that the two vectors have a common point. So to work out XZ, we know XZ is simply XO plus vector OZ. But vector XO, you are going against the vector 2B, so it has to be negative 2B, then plus 2A. Factor out 2. That's our answer for vector XZ. Now we need to work out vector XY. So we've got our XZ already. But before we can work out vector XY, we know XY is simply vector XB plus BY. And BY, since Y is half of BA, BY is half of BA. So we want to work out what is our BA. Our BA is simply vector BO plus OA. And vector BO, we are going against the vector 3B, so it has to be negative. So we have negative 3B, then plus the vector A. Since Y is midpoint of BA, we can work out BY as half of BA. So we now have our XY as XB, vector XB plus BY. Now the BY is half of BA. So work it out separately. Multiply through by half is what we have. So we are now going to replace vector BY with this. And we simplify 1B minus 3.5B. That gives you negative half B plus half A. We factor out half, that's what we have. So now we see that they are all components of negative B plus A. So therefore they are parallel. And the fact that they are parallel and they have a common point Y. Therefore, XY and XZ form a straight line, because first they are parallel to each other and XY lie underneath XZ, or XZ lie on top of XY. That is why we say the two vectors form a straight line. And of course, 2 is a multiple of half, because 4 lots of half makes 2. So that confirms that XZ, vector XZ, is 4 lots of vector XY. And they are parallel first, and they have what? A common point, either X or Y. So the common point and the being parallel confirms that they are straight line. Let's look at example 2. Here we are fortunate all the direction and the vectors are given to us. But we need to understand something here. We are supposed to prove that MC, vector MC, is 3 times vector NM. Let's go step by step by finding what is vector PB first. Vector PB is simply going against vector AP. And you know AP is actually 3B. So PA will be going against vector 3B. So that will be a negative 3B. But AB is going along it, so it's positive A. So you end up having negative 3B plus A. So that is our vector PB. So knowing this as negative 3B plus A for our vector PB, we must first work out what is MC. Then we work out what is NM, then we can compare. So let's work out vector MC. To work out vector MC, we know it's vector MB plus vector BC. And we know vector MB is half of vector PB because it confirms that M is midpoint. So we know BC already as A, but our MB is what we are yet to work out, which is half of vector PB. So this is vector PB. Half of that multiplied through by half, you have this. So replace vector MB by this and simplify. We're going to have 3 over 2 into bracket negative B plus A. I suggest you work on your fractions really well to be able to understand, because half plus 1 is 3 over 2. So half A plus 1A is 3 over 2A. That's why I was able to factor 3 over 2. So I know my MC now. Let's work out vector NM. Vector NM is simply vector NP plus PM. You know vector NP is the same as B. And vector PM is also half of vector PA, which is negative 3B plus A. So I know my vector NP already is B. So I need to work out PM by multiplying half through negative 3B plus A. So that's what I'm going to have. So I'm going to replace vector PM with this. And then I simplify. And when I simplify, I have negative half minus B plus A. So this is NM. Now we need to do a bit of manipulation here. We have MC vector and we have vector NM. So what we need to do is that we are going to multiply vector NM by 3 and see if our answer will confirm this. So this vector half into bracket negative B plus A, I'm multiplying it by 3. And that will give me 3 over 2 into bracket negative B plus A. That's exactly what I have here. So that confirms that really vector MC is equal to 3 lots of vector NM. And it's definitely true that it's a straight line, because as you can see, vector NM and vector MC, you could see that MC is a multiple of NM. MC is a multiple of NM because they are all components of negative B plus A, and they share a common point, which is what? M. M is common to MC and M is common to NM. So the proof is similar to parallel lines, but you need to understand that you need to add the bit of that common point. Okay, our last question on proving that 2 vectors are straight line is this. So we have OAYB is a quadrilateral, and our vectors are already given, directions also given to us. Always check that if it is not, go by the question one by one, do your arrows and put down your vectors. First, let's express AB in terms of A and B. So vector AB. Vector AB is AO plus vector OB. And vector AO is 3A, but we are going against it. So it has to be negative A, and vector OB has to be positive 6B. So we have negative 3A plus 6B. So it's important. The direction is very important. We are going against it, so we need to change direction. So our answer for A is negative 3A plus 6B. You can factor out 3. That's fine. Now, what is important is this. We are going to involve ratio into this now. X is a point on AB. So this is the X such that AX is 1 and XB is 2. So that means that AB is divided into 3 parts, and this is 1/3 and this 2/3. That's the first thing we need to know. Also, we have BY. BY is giving us 5A minus B, which is there already. We are supposed to prove that OX is equal to 2/5 of OY. Right. So now the first thing, as you can see, OY is definitely a straight line. You see it's a straight line. So we're going to still use the same principle. One is a factor, multiple of the other, and share a common point, the same argument. But here we are supposed to prove something here now. So first is to work out what is our OX, what is our OY, and see if we multiply OY by 2/5, we'll get OX. So we start with working our OY. We can start with OX as well, that's fine. So OY, vector OY is the same as vector OA plus vector AY, but you don't know vector AY. You can also say it's the same as vector OB plus BY. So when you're doing these kind of questions, check which information will really help you to work out your vectors. So vector OY is OB plus vector BY. Vector OB is along the direction. Vector BY is also along the direction, so nothing changes. We write what we have and we simplify. So this is what we have for vector OY. Is 5 into bracket A plus B. Now, let's work out OX. OX, we have OX as OA plus AX. And we know AX is a fraction of AB, which is actually 1/3 of AB. So we know our OA as 3A. Let's work out AX separately. We know AX is 1/3 of AB. And from previous working out, we work out AB as negative A plus 6B. So we are going to multiply through by negative 1/3. So multiply through by 1/3. AX becomes negative A plus 2B. Remember, this becomes negative 3A/3 and 6B/3, and that becomes negative 1A plus 2B. So replacing vector AX with negative A plus 2B, this is what I have, and I'm going to simplify that. 3A minus 1A becomes 2A, then plus 2B. Then I factor out 2 to get 2 into bracket A plus B. So I've got my OX vector, and I've got my OY vector. Now what I need to do is that I need to multiply vector OY by 2/5 and see if my answer will confirm the vector OX. So that's what I'm going to do on the next slide. We had OY from the next slide as 5 into bracket A plus B, and we have OX as 2 into bracket A plus B. So if you look carefully, it confirms that one is a multiple of the other. That one is a fact. We can really see that. But to prove, we are going to take OY and multiply it by 2/5. So that's OY. If you multiply by 2/5, The 5 cancels out, and you have 2 into bracket a plus b. But 2 into bracket a plus b is actually what? Vector ox. So that confirms that definitely, yes, vector ox is equal to 2 over 5 oy. And it also confirms that ox is a multiple of what? Oy. And it's definitely a straight line as well, and they share a common point x. So that brings us to the end of lesson 4. Watch out for the final lesson 5, where we go into proper problem solving, finding the scalar or finding the missing ratio. That is proper problem solving involving vectors. That will be our last lesson on vectors. Thank you for watching, and share with your friends.